Okay, then let's have a look at how we solve question 1. So, the table below shows the measurements recorded by a student for a solid metal sphere. The absolute uncertainties in the mass of the sphere and its radius are also shown. We've got the mass, it's weighing in at 100 grams, but it could be as much as 106, it could be as small as 94 grams, and we've got the radius, so it could be a maximum of 1.68 or a minimum of 1.52 centimetres. So the first thing we need to do, is what is the percentage uncertainty in the density of the sphere? Okay, so the first thing we need to look at is that we know that the density is the mass divided by the volume, and the volume of a sphere, let's call that one equation 1, and the volume of a sphere is equal to 4/3 pi r cubed. So therefore the density of our object, we could say, is 3 times the mass divided by 4 pi r cubed. Now, when we look at this, what we can see is we have got the mass is divided by the radius, but the radius is cubed. So what we need to look at is we need to work out what's the percentage uncertainty in the mass, what's the percentage uncertainty in the radius, and then deal with the cubing. The mass is fairly straightforward, so let's just, wrong bit, let's get the pen. So percentage uncertainty in mass. So what we need to know now, what is 6 grams as a percentage of the actual measurement of 100 grams, and that's quite clearly 6 over 100 multiplied by 100, giving me 6%. Now we're going to do the same thing with the radius. So the uncertainty is this 0.08. I have a measurement of 1.6, so we come in and we go 0.08 divided by 1.6, multiply that by 100, and that comes out as being 5%. Now, what we need to do is we need to work out what is the total percentage uncertainty. And obviously what a lot of people did is they went, well, we've got 6% here in the mass, we've got 6% in the radius, so we add those together and that would give us 11%. That is not the correct answer, because of course what we're doing here is we're cubing the radius, so that means that our percentage uncertainty is being fed into the equation 3 times. So therefore we've got percentage uncertainty there of 6, and then because we're doing this 3 times, we've got 15% here, so 6 plus the 15 gives me a final answer of 21%. So our final answer is D.